Hi, for section 10.2, we'll be looking at the law of cosines. So in a situation where you have an oblique triangle, where you're given a side where the angle is included between two sides, or when you're given all three sides, that's the situation in which you would use the law of cosines. Recall that in the previous section, we learned how to use the law of sines. And for the law of sines, you would use the law of sines when you have either an angle side angle situation, an angle angle side, or a side side angle. So that's probably the first thing you should always look for. What are you given? If you're given SAS or SSS, then you use the law of cosines. Otherwise, if you're given angle side angle, angle angle side, or side side angle, then you would use the law of sines. So let's take a look at the law of cosine formulas. Here they are. So when you're trying to solve for a side, that means you would use one of these three formulas. Side is unknown. If you're looking for an angle, then you would want to use the bottom version. So the angle is the unknown. It's actually the same exact formula. It's just isolated for cosine. So this first formula is the same as this one. It's just they solved for cosine alpha, and that became this version here. All right, let's apply this formula here. Let's see what we have. Find the unknown side and angles of the triangle given A is 10, C is 12, and beta is 30. So I'm going to draw an oblique triangle with beta being 30 degrees. All right, so this is my alpha. This is my beta. Let me redraw that beta. Here's my beta, and here's my gamma. Remember, A should be always across from opposite of the angle alpha. B should always be opposite side beta, and C should always be opposite gamma. So let's fill in what we know. We do know that A is 10. We know that C is 12, and that beta is 30 degrees. So this is a side angle side situation because you have the side and then the angle included in between the two known sides. So that's called side angle side. And if you recall, side angle side means we must use the law of cosines. All right, so let's solve for B first. So the way you would solve for B is you would use, since we're solving for a side, we want to use one of these three formulas. And since we're solving for B, we want to use the middle formula. So let's write the middle formula out. Here it is. B squared equals A squared plus C squared minus 2AC cosine beta. So let's fill in the numbers. B squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 30 degrees. Make sure your calculator is in degree mode. And we might as well just take the square root now, since we're going to have to take the square root anyway. So I recommend that you take the square root at this point so that you can just enter this expression exactly as you see it here into your calculator. And if you do that, you should get, let's see what I am getting. I am getting 6. I'm getting 6 for that. So that's B. So let's go ahead and put a 6 here. All right, now once you've done that, now you can go back to the law of sines to find one of the two missing angles. So let's go with alpha. So after you have used the law of cosines to find the side that is missing, now you can use the law of sines. So let's do that. Law of sines. Let's go with alpha. So since we're looking for alpha, I'm going to put sine alpha in the numerator over A is equal to, let's use B and beta because you need to have both pairs known. So sine of 30 over 6. To solve, you multiply both sides of the equation by 10. sine alpha equals 10 sine 30 over 6. All right, and to solve for the angle, we have to take the inverse. So now we can take the inverse of both sides, sine inverse of that entire expression that we have there. And that should do it. If you type that into your calculator in degree mode, you should get 56.4 degrees. So that will do it for that. Let's go ahead and put that into our triangle. So that's 56.4 for alpha. And now we're missing one final piece, which is the gamma. And so remember, whenever you have two known angles of a triangle, the third should be pretty easy because we know that the sum of the three angles should add up to 180. So that means that gamma would have to equal to 180 degrees minus the sum of 30 plus 56.4. And if you type that into your calculator, you should get 93.6 degrees. Okay, so that takes care of that. And we are done here. 93.6 it is. Whoops. Okay, 93.6 degrees. All right, that completes that problem. So now let's try another example. So if you go to the next page, you see that we now have a side situation. So let's draw our triangle first. It doesn't really have to be drawn to scale. Alpha, beta, gamma. A should be across from alpha, B should be across from beta, and C should be across from gamma. Okay, so let's fill in what we know, which is all three sides. 20, 25, 18. Okay. So this is a side situation. Side. Therefore, we need to apply the law of cosines. Law of cosines. Okay. So because we're solving for an angle this time, let's go with alpha. You want to use the one of the bottom formulas. So let me write the correct formula out for us. Cosine of alpha is equal to b squared plus c squared minus a squared all over 2bc. You can verify that that is the correct formula. All right, if you plug in all the numbers and then you take the inverse of cosine, then you will solve for alpha. So let's plug in the values and take the inverse as well. So we should have cosine of alpha equals 25 squared plus 18 squared minus 20 squared all over 2 times 25 times 18. And now we can take the inverse cosine of both sides. You don't even have to work that out. You don't have to really simplify it. You could just go ahead and type it into the calculator exactly as I am writing it out. And that should do it for the angle alpha. Careful when you plug this into the calculator. You may have to put a set of parentheses in the numerator and a set of parentheses in the denominator so that the calculator can do the correct order of operations that we want. Okay, so if you go ahead and solve, you should get alpha is equal to 52.4 degrees. Okay, so that is alpha. Okay, now that we have one of the angles, now we can fall back onto the law of sines. So now let's use the law of sines. And I am going to solve for, I'll go with beta this time. It doesn't really matter. You can solve for gamma or beta. I'll go ahead and do beta. So I'm going to use the law of sines, sine of beta, divided by b is equal to sine of 52.4 divided by a, which is 20. Multiply both sides of the equation by 25. And now you can take the inverse of sine to solve for beta. That's how you solve for an angle. You always take the inverse of the whatever trig function you're working with. In this case, we're working with sine. So sine inverse of both sides gives us sine inverse 25 sine 52.4 degrees over 20. And that is going to equal to, according to my calculator, I'm getting 82 degrees. So that is my beta, or that is beta, 82 degrees. Okay. And of course, once you have two angles, the third angle, you just add those two and subtract from 180. So if I subtract the sum of those two angles from 180, I get 45.6. 45.6 degrees. All right. So that is it for that one. Okay, let's keep going here. We have a application problem. So it says that the applications for the law of cosines and the law of sines would be problems that involve navigation, surveying, and geometry where triangles are formed by distances and angles. So here's a situation where we're looking for a distance. It's a boat that travels 10 miles and turns 20 degrees and then travels another 8 miles. How far is the boat from the port? So notice that there is a picture here. The port is at the bottom, the boat is at the top. Looks like it went due north 10 miles and then it went northwest 20 degrees northwest 8 miles. And so we are looking for the distance between the port and the boat. So let's just call that you can call it anything, any kind of letter that you'd like, but I'll just use A in this case. So here it is, which means this one has to be my alpha. And let's call this one beta, and we'll call this one gamma. That means this one would have to be B equals 10 and C equals 8. Okay, because we have a straight angle here, see this straight angle where alpha is? We know that straight angles are equal to 180, and if this is 20, then we should be able to find this obtuse angle alpha. So it's just going to be 180 take away 20. 180 take away 20 is 160. So now we know this alpha angle. And so now we have a side angle side situation. Side angle side. So once again, law of cosines for that. And our formula, since we're solving for A, we're going to use the formula that is written as A squared equals B squared plus C squared minus 2BC cosine alpha. Okay, you can verify that's the correct formula. And now let's just plug in the numbers. So A squared equals 10 squared plus 8 squared minus 2 times 10 times 8 cosine 160 degrees. Okay, if you plug all that into your calculator, but before you do that, let's take the square root of both sides of the equation so that we can just solve in one single step. Okay, now you can type that into your calculator and you should get 17, let's round to one decimal place, 17.7 miles is the distance between the boat and the port. Okay, let's see what else we have on the next page. Heron's formula. So Heron's formula allows us to calculate the area of an oblique triangle when we know all three sides. So when you have a side, side, side situation, that's when you want to use Heron's formula. So it's pretty simple, as you can see. It's just the square root of S. You may be wondering what S is. It's defined down here. It's defined as the semi-perimeter. The semi-perimeter is the sum of the three sides of the triangle divided by 2. So that's what they define as S, the semi-perimeter. So once you solve, or once you find out what S is, then you can plug it into this formula here. A, B, and C are just the lengths of the side of the triangle. So let's apply it to this first example. As you can see, we do have all three sides. So let's just, let's draw the triangle. Okay, alpha, beta, gamma. A is 10, B is 15, C is 7. So step 1 should be to find the semi-perimeter. So add up the 3 sides, divide by 2. If you do that, you should get S is equal to 16. So we have 16 for S. Okay, now let's use Heron's formula to solve for the area. So it's going to be the square root of S times S minus A times S minus B times S minus C. Okay, type that into the calculator exactly as you see it, and you should get, if we round to 1 decimal place, it should be 29.4. Since there's no units, we can just say square units, since there are no units in this problem. And we know area is in square units. So that is it for that problem. We got one final problem in this section. It's another example of the same thing. So this should not be too bad, I hope, for you. So first up, we don't even have to draw the triangle in this since we pretty much know it's going to look exactly the same as the previous problem, just with different numbers. So let's just find the semi-perimeter. We'll call this one A, B, and C. So 62.4 plus 43.5 plus 34.1 all over 2. For the semi-perimeter, I am getting 70. Okay, and now that we know that, we can use Heron's formula for the area. So it's going to be 70 times 70 minus 62.4, 70 minus 43.5, 70 minus 34.1, and the calculator should give you, if you round to 1 decimal place, I am getting 711.4. And this time we do have some units, meters, so square meters is our units for the area. So that is it for this section.